very first section we're going to go through is 1.1, which is about real numbers and the rectangular coordinate system. So we're going to do four main things. We're going to talk about what is this rectangular coordinate system. Then we're going to talk about Pythagorean theorem, the distance formula, and midpoint of a line segment. So it seems like it's kind of like a mismatch, kind of throw everything together material, but hopefully this first section is mostly review for you. So before we can define that rectangular coordinate system, we have to talk about the types of numbers that we have out there. So the first one that's going to be important for us are integers, and they're really counting numbers, or you can also think of them as negative counting numbers. So the numbers like -5, -4, -3, -2, -1, 0, 1, 2, 3, and the list keeps going in both directions. All of these are going to be integers for us. When we talk about rational numbers, that's just going to take two integers and put them potentially in a ratio. So you can have stuff like -7/4. Technically, all of these integers are also rational numbers because 2 can be written as 2/1. You can have any kind of fraction that you want, like 32/19, also a rational number. When we talk about irrational, however, that's going to be some kind of decimal value that has no pattern and it never stops. So the best kind of examples you can think of, we've probably seen pi at this point, 3.14159. It just keeps going on and there's no rhyme or reason to the actual pattern of it. Square root of 2 is also an irrational number. This, even if you plug it in your calculator, yes, it might stop, but in reality, that decimal just keeps going on forever. So we want to specifically be talking about real numbers, and real numbers can be one of two things. They can be rational or they can be irrational. So when we're dealing with these real numbers, you have a couple different ways that you can express them, but one of the ways is going to be by a number line. So that means we have some line here and we have some kind of count set to it. Typically, we put 0 in the middle, and then positive is to the right, and then if we go in the negative direction, it's to the left. So all of the numbers go in an increasing order, and it represents every number in between 0, 1, 1 and 2, 2 and 3, and so on. When we deal with our rectangular coordinate system, another phrase you might hear called by is the Cartesian coordinate system. This is just formed from two number lines that intersect at a right angle. So we have one number line that is going straight across, and then we have another line that's going vertically. And so they meet at the center point, which is going to be called our origin. So this has coordinate 0, 0, and it's where everything starts or originates from. Okay? So when we move in this positive direction, these are going to be our x values, or if we move in a negative direction. If we go up and down off of this center point, that's going to be our y values. So every single point that we plot here is going to be given by some ordered pair x, y. So this is called a coordinate pair. So this splits basically our two-dimensional or any flat surface into 4 different sections, also known as our quadrants. So in math, we do things kind of counterintuitively. This first axis is our x-axis, y to the sky is our y-axis, and then this first quadrant is where they're both going to be positive. So this is quadrant 1, which we use Roman numerals to do, or you can say Q1. Now, normally a natural move is to go clockwise, but we go the opposite way in math. So quadrant 2 is actually over here, quadrant 3 down here, and quadrant 4 in this bottom right corner. Okay. The number one thing you have to do, especially when we're dealing with graphing, is you want to give a scale to your axes. So I want to go ahead and write what each of these represent. So to the right is positive, to the left is negative, and usually we go at a distance of 1. And then up is positive in the y direction, and and down is negative. Okay. So the reason it's called the rectangular coordinate system is because any point that you plot here, really if you drop a straight line back to each axis, it creates a rectangle. Okay. So the x tells you how far you move in the x direction, the y tells you how far you move in the y. So let's get some practice. We're going to plot these given points, and then we want to figure out which quadrant or axis the point lies in or on, depending on where it lands. So our very first point, A, has coordinates 5, 0. So again, this first coordinate is how far I move in the x direction. So starting at 0, 0, I'm going to move over 5 spaces, and that's going to land me right here. Because my y coordinate is 0, I don't move at all in the y direction. So point A is actually going to land me right here. So since I didn't move in the y direction, this has landed us on the x-axis. For point 2, or for point B, my x coordinate is negative 3, so I'm going to go to the left 3. My y coordinate is positive 2, so that tells me I'm going to go up 2 spaces. And point B is going to land right here. Okay. So point B ends up in quadrant 2. Now point C, my x coordinate is 1, my y coordinate is 3. So I go 1 in the x, and then I go up 3 spaces. Point C lands right here. So that ends up just in our first quadrant, Q1. For point D, I don't move at all in the x direction. So that minus 4 tells us we're going to go down 4. So starting at our origin, I go down 1, 2, 3, 4. And point D will be right here. So that's going to lie on our y-axis. And then finally, we've got point E. So our x-coordinate is negative 4. So I go out to negative 4. The y-coordinate is negative 2. So I go down 2. And point E lands us right here. So that ends up putting us in quadrant 3. So before we can get to our 2 topics after this that actually deal in the rectangular coordinate system, we've got to go through the Pythagorean Theorem. So hopefully at some point you've heard this, at least the name. You might not remember the exact formula, but what it does is it helps us find some kind of connection between the side lengths of a right triangle. So this is very specific, though. It only works with a right triangle, meaning that your triangle has a 90-degree angle. So what our Pythagorean theorem tells us is a squared plus b squared equals c squared. What those actually are of the triangle are a and b are the sides that form the 90-degree angle, and c is the side across from the 90-degree angle. It's also called our hypotenuse. So side C is the hypotenuse, and it's the longest side of the triangle. And sides A and B are called the legs. They form the triangle. So let's try a quick example. We want to use this given triangle to find the length of the unknown side. So my right angle here is right there. So 10 is going to be the angle, the side across from it, which is the hypotenuse. And these other 2 sides that form the right angle are the legs. Okay. The thing we want is a leg. I don't know what it's called. You can call it A or B if you want, but typically if we don't know something, we call it X. So I'm going to say we need to solve for this side X. So using our Pythagorean theorem, we take one leg squared, add to it the other leg squared, and it's going to equal our hypotenuse squared. And then from here, we just have an equation that we have to solve. So this gives us x squared plus 36 is equal to 100. And we're going to go through solving different kinds of equations, but for this, we want to get the x squared on its own. So we're going to go ahead and subtract 36 from both sides. That leaves us with x squared on the left and 64 on the right. And then at this point, to be able to get x on its own, we've got to take a square root. And I'm going to be pretty precise here because I don't want us to get into bad habits. Technically, anytime you take a square root, you get a plus or minus out front because there's actually two possible answers. We have plus or minus 8. Okay? So kind of going back to this equation at this step, you're looking for a number squared equaling 64. There are two possibilities. 8 times 8 gives us positive 64. But also, if I take negative 8, negative 8 times negative 8 gives us positive 8 as well. So there are two answers. Now that being said, this is the side length of a triangle, so I don't have to worry about this negative case. A side length is always going to be positive. Okay. So again, it's not a super big deal right now, but later in the future, we want to get in this habit of anytime we take a square root to put a plus or minus out front. So now that we've got a little bit of a hang with that, let's go ahead and talk about how can I find the distance between 2 points. So we're going to try to actually come up with this formula. I have my first coordinate pair, which is x1, y1. My second coordinate pair is x2, y2. And what I want to do is I want to see if I connect these with a straight line, what is the length of this line, which is called d. Okay? And this is where our Pythagorean theorem actually comes into play. So I'm going to create a right triangle within here. So I extend a straight line in the x direction, a straight line in the y direction, and those are going to meet and form a right angle. Okay? If I want to think just kind of conceptually, not with numbers, what this is it's really how far you're moving in the x direction. So this side over here is really the difference in our x values. Okay. So if we want a formula for that, it honestly isn't going to matter which one you put first and second, but I'm going to say x2 is the bigger number, and we're going to subtract x1. So if you need kind of numbers as an example, if your first coordinate started at 0 in x and went to 7, the difference in those x values is 7. That's how far you travel in the x direction. If one started at 2 and then the other one ended at 9, still I'm going to travel a distance of 7 in the x direction. When we deal with this vertical side, same kind of idea, but now I'm seeing how far my y is changing by. So this side length is actually the difference in the y values. So again, I'm going to assume y2 is the bigger one, and I take away the starting point, y1. So if my y traveled from 1 to 6, this side length would be 5. So what we've really done is we've made a right triangle. x2 minus x1 is one leg, y2 minus y1 is another, and then our distance is the hypotenuse. So using our Pythagorean theorem, the hypotenuse squared is the one side squared plus the other side squared. Okay? And then you just want the distance on its own, so just like we did in the last example, you take the square root. So I take the square root on this side, and I take the square root on this side. I don't need to worry about the plus or minus because it's a distance, it's a positive number. So our distance is equal to the square root of the difference in x values plus the difference in y values, each of those squared. Okay? So this right here is our distance formula that we can use now. You don't need to memorize how or the proof of this, but I think it's always beneficial when we can to see where things come from. So let's try an example. We have 2 points, -5, +4, and 6, -1. We want to figure out the distance between these points exactly, and then afterwards we're going to round. So be very, very, very careful, especially in your homework and your test. You want to read the directions to see which form you want, because a lot of times you're going to get irrational numbers for your answer, and you don't want to input the decimal approximation. So let's give this a shot with our distance formula. Again, I'm just going to rewrite the whole thing first. We do the difference in x values squared plus the difference in y values squared, all underneath the square root. Okay. It really makes zero difference which one you pick to be x1 and which one you pick to be x2. I would just always tell you to stay consistent. So here's our two x values. So underneath our radical, I'm going to do 6 minus -5 squared. So that's the difference in x values. And then we're going to add the difference in y values. And again, you want to just try to stay consistent. I made this the first one, so I'm going to make this the first one. It really won't make a difference for this problem, but in other instances, it does. Okay. So we've got the difference in y values squared. So this gives us the square root of really 6 plus 5 squared. And then that we can actually condense right away. It's -5 squared. So really this gives us 11 squared plus 25 under our square root. 11 squared is 121. And then we're going to add 25. So this gives us 146. So this right here is the exact answer. Okay. Now, if you go ahead and plug this into your calculator, then you can round it to 2 decimal places. This is about 12.08. So this is our decimal approximation. So again, just double check what your directions say. If it says to round, then you know you can plug it into the calculator. But if it does not say to round, that means it wants something exact. And typically it wants it fully simplified. Now on a similar note, now let's talk about how can we find the midpoint of a line segment. So again, if I have 2 points that are in the Cartesian plane, I want to figure out what point is exactly halfway in between. So basically think if we go ahead and connect these with a line, I'm looking for the point right here, so that when I take the distance from here to the midpoint, and then from the midpoint to the other, these two are exactly equal in length. So I'm going to call this point XM, YM to represent the midpoint. Okay. And really, this just comes from the average. So if I want something that's halfway in between, I'm going to take the mean of the two of them. So our midpoint formula, it's going to give us a point, so we get a coordinate pair. I want to go ahead and I want the average of the x values. So we add the x values together, divide by 2. And then same exact thing for the y values. We add them together and divide by 2, and that gives us the number halfway in between. So let's try a single example. We're going to find the midpoint, and then we're also going to graph it so you can kind of see that, yes, this is working out how I want it to. So we're just going to jump into finding it. We're going to have a coordinate pair, so I need to make sure I write it as a pair. I want to go ahead and I want to add the x values together. So that's -5 plus 6, and then we'll divide it by 2. So that's the average of these numbers. And then I'm going to do the same thing with the y values. We add them together, so it's 4 plus -2, and then we go ahead and we divide by 2. So going through these calculations, -5 plus 6 is going to be 1 over 2. And then 4 plus -2 is 2 divided by 2. So that really ends up giving us 1/2, and then 2 divided by 2 is 1. Okay. So if I go ahead and graph these, I can see that, yes, that's roughly the midpoint. Of course, we're not going to be 100% accurate by hand. So we need to go out 6 in every direction because one of our points is 6. So might as well just be consistent. 1, 2, 3, 4, 5, 6. Last one, 1, 2, 3, 4, 5, 6. So our very first point is at -5, +4, which is right here. And the second point is at 6, -2, which is down here. So if I were to connect these with a straight line, and now I plot my midpoint, which is at 1/2, 1, it does indeed look like this line segment is exactly the same length as the other line segment.